Hi everyone, this is Addison Altman, and today we're going over lesson 14.7, which is Catalyst. So my first slide is, what is a catalyst? So a catalyst is a substance that increases the rate of a chemical reaction without being permanently changed or consumed in the reaction. So it does this by providing an alternative reaction pathway with a lower activation energy. So, in other words, it makes reactions happen faster and more efficiently. So, how do a catalyst exactly work? So, with every chemical reaction, you have an activation energy. So, if your activation energy is super high and like the energy over here is like not you don't produce that much energy in the long run, so then this like jump from xy to z is actually positive. That's when you get an endothermic reaction, and exothermic reactions are favored, so you want a lower activation energy. So how a catalyst does this is you have more like the original reaction, you only had one step. But in this, with the catalyst, you add uh, one, two, three, four. Four different stages you went to get the final product. So you have a lot more intermediates when you have sometimes a catalyst, but in the end, it creates a certain pathway that just has this lower activation energy, so it's a more favored reaction. So there are two different types of catalysts, and they're pretty straightforward what the difference is between them. So homogeneous catalysts are in the same phase as reactants, so you can just tell that by the prefix homo that it's the same. So if I have like my catalyst, this is not a real example, so don't discard it. But say like I have nitrogen gas and like oxygen gas, like those two are in the same stage, so that's why it's here's an actual real example. So for example, in the decomposition of ozone, chlorine atoms act as the catalyst in the gas phase, so it works when both reactants, ozone's not necessarily a reactant, it's being decomposed, but chlorine is in the same phase. But like heterogeneous catalysts are in a different phase than the reactants. So a common example is the use of solid platinum in catalytic converters to speed up breakdown of harmful gases in the exhaust. So the catalytic converter is like it's a solid, and so the gas goes through there, and that's where they're breaking down harmful gases, but the catalyst is in a different phase of matter than the reaction, so that's why it's different. Okay, next is just a general example of a catalyst. So here we have, sorry for my really, really bad writing, I didn't know a better way to do this. We have the decomposition of hydrogen peroxide. So this is very similar to the lab that you guys will be doing. So in this, they use, oh my gosh, manganese dioxide to help speed up the process of breaking hydrogen peroxide into water and oxygen gas. So what goes on here is when you write the symbol like this, the catalyst goes over this, because in reality, it's reacting over here, but it's also being produced over here. So that's why it's just speeding up the reaction and not actually a part of the balanced equation. But what you would have that I don't have on here is that there are those multiple steps. So you have the fast step, the slow step, and like you have all these different intermediaries. And what the catalyst does is it inserts itself, so you might end up with like at one step, like I don't know, oxygen, or like you might have like hydrogen and manganese together in kind of weird combinations, but it does this by making other compounds that are more easily decomposed into what hydrogen peroxide breaks down into. So you really don't have to figure out the steps, but the whole part of this unit is, I would say that if you're struggling to understand catalysts, there's probably something that you missed in earlier steps. Really, it's the general like base knowledge that like you guys have to know with this is that they help speed up the reaction by providing an alternative path with a lower activation energy. And so it can do this by just giving an alternative path, like I was saying, but by making like different intermediaries and just bringing this on a different path to also achieve the same result. And so that's pretty much all catalysts do, and that's all you need to know. Okay? Good luck on your tests, everyone. And yep, thank you for watching.